Okay. Good evening, everybody. My research is a bit different, I would say, compared to all this research that has been presented. So I have 10 minutes. Thank you again for Ms. Nero. My research for today, this was my research for my degree study. So I think it would be nice if I can share about the findings of this research. And this is the research of microplastic contamination in Tuna Kawakawa, or scientifically known as Euthynnus affinis in Malaysia. If you don't know what is Tuna Kawakawa, do you know nasi dagang? People in Kelantan maybe eat nasi dagang every day for breakfast. So in nasi dagang, there are ikan tongkol, and this is the ikan tongkol. Okay. Okay, so objective of this research, actually, we want to actually see, are there actually microplastics in ikan tongkol? Is it really there? Like, I want to see with my own eyes if it's there or not. So this research has been done in a very controlled condition. We purchase our sample from the pasar where we all buy our fish to cook. And in Mahmal already, we make sure that everything is in control condition so we can avoid any contamination from the lab itself. Okay, the objective of this is we want to see if there is really microplastic in our food. It started from the pollution, of course, pollution that is caused by our human activities, that now can be detected in all oceans, Pacific Ocean, Indian, Atlantic, everywhere can be detected. And this anthropogenic pollution consists of both particles that are small, that cannot be seen by our naked eyes, and also bigger size waste. It's not only plastic, maybe there are glasses, metals, and so on. But the main component of this anthropogenic waste are plastic. And from the year 1950 to the year 2018, about 6.3 billion tons of plastic have been produced worldwide. And this amount, we can easily assume that after COVID pandemic, this amount is possible to be doubled by now. But among these 6.3 billion tons of plastic that has been produced up until 2018, only 9% of them has been recycled. And the rest, they pollute. Some stay at the dumpster, some went to the land, some accidentally go to the river, and some end up in the sea. Okay, there has been a growing concern about the contamination of microplastic, because if plastics like this, the bottles, the plastic bag, the fishing net, we all can see it with our eyes. It can easily be seen. But microplastic, we cannot see it. So it might be in our drinking water. It might be in our dinner plates. We cannot see it. And there are two types of microplastic. The first one is primary and secondary. Primary microplastic consists of the for indirect use, such as polymer product material, like our water bottle. If we put hot water in our Tupperware, it's possible to release the microplastic in our water. Okay, and then the secondary is the breakdown of larger plastic materials into smaller fragments as a result from the fermentation. We purchase fish, Kawakawa tuna or tongkol from 4 different states in Malaysia, in Mersin, Kuala Terengganu, Kuala Selangor, and Kuantan. And we use 69 ikan tongkol. For sample preparation, we dissect and then we digest using the potassium hydroxide to make sure that we dissolve all the organic material, and we put in the oven for 7 to 2 hours. And then we filter through stainless steel with 3 different sizes, and the residue on all seed we filter using microfiber filter, and then it's dried overnight. So, and then we identify the result visually and also chemically, and give statistical result. As a result, a total of 1,861 microplastics were found in this ikan tongkol. And from the 69 Kawakawa fish, I have taken 3 samples from each fish. GIT is the gastrointestinal, which is the stomach, and the gills and also the muscle. The muscle is the flesh. And the flesh that is taken from the fish is the area of the dorsal, which is the upper part, the most delicious part of the fish. Okay, so a total of 1,861 means one fish contained approximately 26.9 microplastic. We can see here that Terengganu were the highest with 20 fish we take from Terengganu, 574 pieces of microplastic were found in this fish. So we did some research and we assume that the low water quality and high amounts of pollutants in Terengganu estuary were due to anthropogenic activities like tourism and also construction. And in fish organs, we can see here that the lowest one is in gills, and GRT and muscle have high amount of microplastics. Variation of in different sex, male have slightly higher microplastic contamination than female. And because we did the sampling during the spawning season, we assume that the males, they travel to a lot of places and they eat foods from a lot of places. That's how they ingested more plastics than females. And here is our next finding. Male fish eats more plastic than female. Maybe they didn't just purposely eat the plastic, but maybe they eat more because it's the spawning season. That is why. For the morphotype, most microplastics that we found consists of fiber, which is our clothing, maybe fishing trawls, or water waste from washing textile, and then also fragment as the effect from weathering from the bigger plastic. And for the color, mostly is black and blue, followed by red. The study before this found out that the second most common particle color was blue, which may be related to misidentification of bioluminescent marine organisms such as copepods because they have emit the light in blue wavelength inside the ocean. And darker colors like black and blue, they are easier to detect. So these fish, they just eat everything that they can see. So they might have mistaken this plastic for food. For the sizes, this is the interesting one. If you can see the total, the size, mostly the smallest one, which is 0.001 to 1 millimeter. But the D1 is the microplastic range in the flesh. The size is bigger, which is 2 to 3 millimeters. So we assume that it is because in the pasar, they will cut the fish and they will put the fish inside the plastic bag. And this plastic bag and the cutting board, it contaminates the fish with the microplastics. That is how the fish flesh ended up with bigger size microplastics. Chemical composition, mostly rayon, which is our clothing, and also fishing trawls. Exposure to human, we can see, before this people were like, oh, it's fine, microplastic were in GIT and in gills, but prior cooking, we'll remove them anyways. It's not that we will eat them, right? But in this study, it has been proven that the microplastic is the highest in the flesh, which we eat. And it's not easy to remove by just rinsing the fish. In conclusion, these studies have proven that eating this Kawakawa is also one of the biggest cause to as a root for microplastic intake in human. And if we take too much microplastic, there will be negative impact on us. So that is all from me. And here is a bit of the picture that I can share, the microplastic with different colors and also different amount of type. Thank you.